Baalbek, which is located in Lebanon, and I had the great privilege of going there in September of last year, exactly 1 month before things kicked off in Israel.
What if the greatest marvel of Baalbek isn't its towering Roman columns, but what lies hidden beneath them? An ancient foundation so vast and precise that it defies conventional explanations of Roman engineering.
Baalbek's sprawling complex is home to some of the most impressive Roman ruins around.
Imagine stone blocks weighing up to 1,600 tons.
Most likely, the limestone formation was located in this way, and the strength of the block was maximum.
Cut with near-perfect accuracy and placed with a level of skill that even modern machinery would struggle to match.
Over that side is the 1,650-ton stone that was found, rediscovered, and dug out.
Beneath one of Rome's most impressive temples rests an engineering mystery that has puzzled experts for centuries, challenging our understanding of ancient technology and raising a provocative question. Who truly built Baalbek's colossal foundations, and how? The impossible foundation. Standing at Baalbek, most visitors are immediately struck by the towering Roman columns and the grandeur of the temple complex above.
And the jewel of Baalbek, the temple of Bacchus.
But beneath those impressive ruins lies a foundation that should not exist. Massive stone blocks precisely cut and fitted with astonishing accuracy. These megaliths are so heavy that engineering experts today struggle to explain how they were quarried, transported, and positioned with such precision over 2,000 years ago. The sheer size and craftsmanship of this foundation immediately raised the question: was this really a Roman construction, or something far older and more mysterious? The foundation is composed of enormous limestone blocks, some weighing as much as 1,600 tons, heavier than 3 fully loaded jumbo jets stacked together. Unlike the Roman structures above, which use relatively manageable stones, these foundation blocks dwarf anything Rome is known to have moved or worked with elsewhere in the empire. Their surfaces are so smooth and perfectly matched that not even a sheet of paper can slip between the joints. This isn't just monumental stonework. It defies the limits of what Roman techniques should have been able to accomplish. This exceptional foundation sits quietly, overshadowed by the visible temples above, which tell a more complete and documented story. But the engineering behind this base presents an enigma that scholars and engineers have wrestled with for centuries. How could ancient builders, using the tools and technologies recorded from that era, manipulate stones of such unimaginable size with millimeter precision? The foundation seems to outmatch even the most celebrated Roman marvels, such as the Pantheon or the Colosseum. The mystery deepens because these monolithic blocks aren't just laid side by side. They interlock with surrounding stones through intricate jointing techniques, forming a platform resistant to earthquake damage that has stood through multiple seismic events. This level of precision suggests knowledge of load distribution and engineering far beyond what is traditionally attributed to the Romans. If the foundation was not their work, then who built it, and why? Adding to the puzzle is the absence of any Roman record, inscription, or engineering diagram describing the construction of this extraordinary base. Throughout their vast empire, the Romans prided themselves on documenting monumental building projects. Yet here, where the foundation blocks defy explanation, there is complete silence. This nearly deafening gap in the historical record challenges the conventional narrative of Roman accomplishment. But the foundation's story does not stop at its massive stones. From a nearby quarry, some of the largest uncut blocks ever discovered await, suspended in the bedrock where they were abandoned mid-extraction. This halting of work hints at a sudden interruption or decline in the civilization that undertook such a project. The presence of these giant megaliths yet to be moved suggests a story interrupted, one unfinished and shrouded in mystery. The foundation's sheer scale, precision, and the sudden abandonment of quarry stones raise the possibility that this is not a Roman foundation at all, but a legacy of builders lost to history. Such an idea reframes not only Baalbek, but our understanding of technological development in the ancient world. The root of this mystery will unfold as we examine the limits of Roman engineering and then the incredible specifics of the trilithon stones, which define this architectural wonder. Exploring the known feats of Roman engineering offers a stark contrast and allows us to appreciate just how outsized the Baalbek foundation really is.
So now we're at the Baalbek temple location, and what we're looking at the bottom is one stone.
The Roman legacy and limits. The Roman Empire is famed for some of history's most celebrated engineering feats, from massive aqueducts that still channel water today to the Colosseum's vast amphitheater and the Pantheon's awe-inspiring dome. Roman engineers mastered concrete, arches, and precise masonry, stretching the boundaries of construction technology for their time. Their ability to organize labor, materials, and logistics created enduring monuments that shaped Western architecture. Yet, even these achievements pale in comparison to the gargantuan blocks found at Baalbek's foundation.
So something happened at Baalbek in the ancient past, causing work to stop.
Official Roman records, such as those written by Pliny the Elder and Vitruvius, detail the empire's construction and engineering methods in great depth. They describe the tools, materials, and manpower used for their projects, none of which indicate handling stones anywhere near the size found at Baalbek. The largest stone blocks documented elsewhere in the empire, like the columns of Trajan's column or Egyptian obelisks transported to Rome, weigh at most 300 tons, far lighter than the 800 to 1,600-ton megaliths here. Roman cranes, pulleys, and lifting mechanisms had known limits during this period, never approaching the scale necessary to move Baalbek's foundation blocks. Terrain, lack of steel cables, and incomplete knowledge of large-scale logistics make the theory that Romans quarried and placed these stones incredibly difficult to sustain. Moreover, no inscriptions, engineering plans, or historians from the Roman period mention this extraordinary stone-moving feat, a silence uncharacteristic of Rome's known documentation culture. This gap suggests that these colossal stones at Baalbek might not be the product of Roman ingenuity, but rather remnants of an older, perhaps forgotten engineering tradition. The Romans were pragmatic builders and often incorporated existing structures when conquering new territories. Baalbek's architectural style displays classic Roman aesthetics and decoration on top of a foundation of unfamiliar construction techniques, hinting that Romans built upon something already in place. At the same time, Baalbek's temples are among the largest and most grandiose religious complexes in the Roman Empire, featuring towering columns 22 meters high and massive courtyards designed to inspire awe. The juxtaposition of standard Roman building practices above and unmatched megalithic masonry below creates a striking architectural duality. This contrast raises questions about the origin, technology, and intent behind the enigmatic foundation beneath. Roman builders were known to leave inscriptions that proudly declared their contributions. The complete absence of any credit for the enormous foundation stones in Baalbek contradicts this tradition and adds a layer of intrigue. Why would Romans neglect to record one of the most impressive building achievements in their entire empire? The failure of Roman engineering explanations invites a closer look at the stones themselves, especially the iconic trilithon blocks forming the western wall of the podium. These monoliths stand as silent giants that embody Baalbek's deepest secrets. Understanding their scale will help us grasp the full magnitude of the engineering challenge faced by whoever built this foundation. By comparing these trilithon stones to other famous megalithic constructions worldwide, we begin to see why Baalbek stands apart, and why the story of its builders is still shrouded in mystery. The scale and precision of the trilithon blocks turn what seems impossible into something tangible, challenging our assumptions about ancient capabilities. The trilithon stones. Among Baalbek's most astonishing features are the 3 trilithon blocks forming part of the western wall of the temple podium. Each stone measures roughly 19 meters in length, 4.2 meters in height, and 3.6 meters in depth, weighing around 800 tons apiece. Some estimates push their weight closer to 1,000 tons, depending on limestone density. These are not just big stones. They are among the largest accurately cut and positioned blocks of ancient times. To put their size into perspective, the largest stones used in Egypt's Great Pyramid weigh roughly 80 tons, making each trilithon block about 10 times heavier. At Stonehenge, the heaviest stones are barely 25 tons, making the trilithon seem almost unimaginably colossal by comparison. These giants tower far beyond even famous megalithic monuments, representing a level of construction rare in ancient infrastructural history. The extraordinary size of the trilithon blocks challenges conventional ideas about how ancient peoples could quarry, transport, lift, and fit stones of such gargantuan proportions. The quarry from which these trilithons were cut lies approximately 800 meters away, but separated by uneven terrain. Foam of a feat nearly impossible with Bronze Age or Roman-era tools. Moving these stones across rugged ground would have required innovations lost to history or techniques beyond those conventional civilizations ever developed. Even more remarkable is that these massive stones were lifted approximately 7 meters above the ground and fit together with near-perfect precision. The joints are so tight that not even a single sheet of paper can fit between them. This level of millimeter accuracy is impressive by modern standards and utterly bewildering when considering pre-industrial technology. The trilithon stones also interlock with surrounding masonry, creating a foundation platform designed for enduring stability. This technique not only prevents movement, but has helped the structure survive multiple seismic events over millennia without cracking or shifting. Such knowledge implies an understanding of physics and engineering surprisingly advanced for any ancient culture in the region. As awe-inspiring as the trilithon blocks are, they represent just part of an even larger mystery. Nearby quarry stones like the stone of the pregnant woman and another estimated 1,650-ton block remain abandoned, suggesting quarrying was interrupted abruptly for reasons unknown. These unfinished megablocks hint at ambitions halted before completion, intensifying speculation about the civilization behind this extraordinary architecture. The sheer physical and technical demands these stones represent force a re-examination of who created Baalbek's foundation and how it was achieved. Whatever the answer, the trilithon blocks remain a monumental testament to an engineering prowess long lost to time, hiding secrets beneath layers of history and power. The story behind these stones is inseparable from the massive quarry and abandoned monoliths, where an interrupted ambition reveals a history waiting to be uncovered. Exploring the quarry stones reveals clues to a construction saga that spans centuries and civilizations. Quarry mysteries and abandoned stones. Just 800 meters from the temple complex lies the quarry that fed Baalbek's monumental foundation, a place that holds its own mysteries. Among the largest stones here is the Stone of the Pregnant Woman, a massive block still attached to the bedrock, abandoned mid-extraction. Measuring about 20.5 meters long, 4 meters tall, and 4.5 meters wide, its weight is estimated at over 1,000 tons. The very presence of such an enormous unfinished stone hints at a sudden halt in the ambitious construction project. In 2014, archaeologists discovered an even larger block beneath the quarry, estimated to weigh a staggering 1,650 tons. Nearby, a third massive stone rests, similarly precision-cut and shaped, but left unused. These were clearly not random natural boulders. They were carefully quarried, shaped with extraordinary skill, and intended to be transported to the temple site. The fact that these stones remain in place suggests that whatever force halted the project was powerful enough to stop monumental work midstream. The decision to abandon these enormous stones raises questions about the builders and their fate. Was their civilization interrupted, collapsed, or perhaps conquered before completing this incredible foundation? Such an abrupt cessation adds to the mystery and challenges us to consider what historical upheavals might have occurred. These incomplete stones stand as silent witnesses to a story abruptly ended, their massive size a reminder of the lost ingenuity behind their creation. Transporting such colossal stones over uneven terrain using Bronze Age or early Iron Age technology seems almost impossible. Without steel cables, wheels, or sophisticated lifting machinery, moving stones weighing hundreds or even thousands of tons would require an extraordinary system, one for which there is no surviving evidence. The terrain between the quarry and the temple is not flat, making the task even more daunting and raising the bar for ancient engineering prowess. Some propose that ancient builders used rollers fashioned from Lebanon cedar, one of the hardest woods available. These rollers would have needed to be at least 1 meter in diameter to support the massive weights, but they would also break and splinter rapidly, demanding continuous replacement. Coordinating thousands of laborers to move stones in perfect unison requires communication systems and logistics for which no records exist, and engineering experts remain doubtful that such methods alone could achieve these feats. The nearby quarry stones, abandoned and unfinished, highlight that not only the technical challenges, but also organizational and societal factors may have contributed to halting progress. Whether natural disaster, war, or internal societal collapse caused this interruption is unknown. But the quarry remains a frozen moment in time, a snapshot of a grand vision cut short. Its presence invites us to imagine the ambitions of a civilization far beyond surviving Roman occupation. The scale of the unfinished stones also emphasizes how extraordinary the completed trilithon blocks are. Stones that, despite their size and weight, were transported and fitted into place. The quarry's mysteries deepen the sense that Baalbek's foundations were the work of a culture whose knowledge and capabilities vastly surpassed what we associate with the region's known historical occupants. Their disappearance poses one of the greatest enigmas surrounding this ancient site. From these towering and abandoned blocks, we glimpse the magnitude of the original construction plan. Monumental not only in stone but in intention, the quarry's story compels us to ask what happened to the builders and whether their secrets lie buried or lost altogether. More importantly, it sets the stage for understanding the technical challenges involved in using stones of such immense size and weight. The question remains, how did these ancient builders not only quarry, but also move and position stones of this scale with the tools they supposedly had? Engineering challenges and techniques. Moving megalithic stones weighing hundreds or thousands of tons across rugged terrain presents an almost unimaginable engineering challenge, especially without the modern technology we rely on today. Theories about how Baalbek's builders accomplished this typically involve wooden rollers, ropes, and manpower, but the practical limitations of these methods quickly become apparent. Each stone's weight placed enormous stress on any transport system and required a level of coordination and force that remains difficult to reconcile with known ancient capabilities. Consider the problem of rollers. Wood, even the hardiest cedar of Lebanon, would crack and splinter under such loads, necessitating their constant replacement. Given the length of the journey and the size of the stones, thousands of rollers would be needed, relayed from back to front continuously as the stone was moved forward. This process alone requires precise organization, sufficient resources, and constant material supply, complicating the already enormous task. Even with perfect rollers, the act of pulling stones, this massive requires an immense workforce. Calculations estimate between 10,000 and 40,000 laborers working in concert. Keeping so many people coordinated, motivated, and effective over the full distance and through challenging terrain demands logistical and communicative capabilities rarely attributed to ancient societies in this region. No historical or archaeological record confirms the existence of such organized labor forces or the communication necessary for this task. Once at the temple platform, the stones had to be lifted roughly 7 meters, a feat that strains credibility given the absence of steel cables, hydraulic lifts, or large-scale pulleys. The terrain and lack of mechanical advantage raise questions about what techniques might have been employed. Bronze Age or early Iron Age tools, limited to simple levers, ropes, and wooden structures, provide few answers to this puzzle. The precision required to fit the stones together with millimeter accuracy suggests the lifting and placement were just as carefully controlled as the quarrying process itself. The interlocking joints between stones eliminate the need for mortar, perfectly binding the megaliths against earthquakes and movement over millennia. Such precision indicates surveying and engineering sophistication rarely seen in any contemporary culture. Roman engineering, famous for monumental achievements, never documented or demonstrated working with such enormous weights in their empire. While they moved obelisks and columns of a few hundred tons, stones more than twice that weight remain outside the scope of Roman apparatus. Their pride and obsession with recording engineering triumphs makes this silence on Baalbek's foundation especially puzzling. Modern attempts to replicate moving and placing Baalbek's blocks using period-appropriate technology have failed to meet the challenge. Without modern cranes, winches, or steel cables, the feat seems nearly impossible. This has led some engineers to speculate on alternative methods or lost technologies, though such ideas remain controversial. Despite the silence of ancient records and absence of physical evidence of advanced machinery, the engineering reality remains. Whoever built Baalbek's foundations achieved what should have been impossible for the time. This forces a reconsideration of what we know about ancient construction methods globally. Understanding these challenges makes it even more surprising that the stones were not only moved but integrated into a foundation that withstood centuries of earthquakes intact. Such resilience invites deeper exploration into the unknown methods and civilizations that might have laid these monumental foundations. The unexplained precision and strength of Baalbek's foundation lead naturally to questions about construction techniques that differ radically from those historically attributed to the Romans. Mysterious construction methods. Beneath Baalbek's colossal stones lie traces of craftsmanship that don't quite match what we know of Roman stonework. Engineers studying the foundation have noted that the tool marks on these megaliths differ significantly from those left by Roman chisels and picks. Instead of rougher, hand-carved patterns, the surfaces suggest the use of abrasive cutting techniques, or possibly saws and wire systems capable of maintaining perfectly straight lines over long distances. Such technology is not documented anywhere else in Roman construction. German engineer Dr. Gerhard Kepler, who closely examined Baalbek's stones, pointed to the possibility of advanced cutting methods, perhaps involving materials or tools lost to history. The smooth faces and sharply defined joints imply a precision that would have required consistent pressure and a methodical approach far beyond hammer and chisel. This level of stone finishing seems almost inconceivable for the era and region, opening the door to speculation about unknown or forgotten technologies. Even more fascinating is how the trilithon blocks interlock through carefully engineered joints, fitting together without mortar or filler. This method not only ensures stability, but also allows for micro-movements during seismic activity, preventing damage. The design reflects a sophisticated understanding of structural engineering, grasping concepts of load distribution and material behavior that feel ahead of its historical context. No known Bronze Age or Roman-era tools match the evidence of these cutting marks. The smooth, flat surfaces hint at the use of abrasives or cutting techniques more commonly associated with modern industrial methods. If these assumptions hold, it means the builders of Baalbek employed tools and processes for which history has no record, suggesting a lost level of technological advancement. This mystery extends to the logistics of transportation and placement. Moving blocks that weigh nearly 1,000 tons up and around uneven ground would have posed technical barriers that the ancient world could only dream of overcoming. Yet the stones are not only transported, but are set with millimeter precision, evidence of exacting survey and placement technology. Some researchers propose that these builders had access to tools or methods unimaginable to their contemporaries, perhaps timber or metallic systems capable of generating sufficient force, or even techniques based on principles that remain elusive to us. It's a tantalizing glimpse into a possible ancient engineering sophistication lost through time. Despite these clues, there is no direct archaeological evidence of these advanced cutting or lifting devices at Baalbek.
We're here in Bednail. It's one of the hardest hit villages in the Bekaa Valley, nearby Baalbek.
No fragments, no manuals, no depictions survive. Only the stones themselves silently testify to their creator's skill. This lack of tangible evidence fuels debates and alternative theories regarding the origin and nature of the builders. The unexplained precision and craftsmanship of Baalbek's foundation stones continue to challenge scholars and engineers, suggesting that those who built this platform operated with a technology and knowledge far removed from the established historical timeline. Their methods remain a profound enigma, casting doubt on the straightforward attribution to Roman builders. The puzzle of how these stones were crafted and assembled naturally leads us to examine the competing theories surrounding Baalbek's origin and the identity of its mysterious builders. Theories on origins. Baalbek's foundation has sparked considerable debate among archaeologists, historians, and engineers, producing a range of theories to explain its astounding construction.
But Baalbek, which is located in Lebanon, and I had the great privilege of going there in September of last year, exactly 1 month before things kicked off in Israel.
The conventional Roman theory holds that the entire complex, including the foundation, was crafted by Roman builders. Proponents argue Roman engineering was more advanced than generally assumed, and that the absence of detailed records represents a gap rather than impossibility. However, this struggles to explain why such techniques are unique to Baalbek and not found elsewhere in the empire. Another prominent theory credits the Phoenicians, skilled builders and traders who occupied Lebanon long before Roman occupation. Yet, no known Phoenician structures come close to the scale or complexity of Baalbek's megalithic platform. Their engineering methods, while impressive, do not match the precision cutting or the sheer size of the blocks. This leaves considerable doubt about their capacity to build such a foundation without outside influence. Perhaps the most intriguing hypothesis suggests a lost or forgotten civilization, an earlier culture, possibly Bronze Age or predating it, possessing advanced engineering knowledge now lost to history. This civilization may have developed unique techniques for quarrying, moving, and fitting massive stones that were never documented or subsequently vanished. The sudden abandonment of quarry stones supports the idea of a cultural collapse or interruption, leaving behind their monumental platform. Another variation of this idea is the inherited foundation theory, which proposes that later civilizations, including the Romans, inherited this megalithic base and simply built their temples atop it. This would explain why Roman-style structures sit atop a foundation unlike anything else in their known repertoire. Using an existing massive platform would save monumental effort and resources, making Baalbek an attractive location for grand religious construction. Occasionally, more speculative ideas arise, suggesting ancient builders may have harnessed technologies lost to modern science, such as advanced counterweight systems or even controversial concepts like acoustic levitation. While such theories remain fringe, they echo the reality that many ancient technologies, like Damascus steel, Roman concrete, or Greek fire, disappeared and were rediscovered centuries later. The possibility of lost methods keeps the mystery vibrant. Radiocarbon dating and weathering analyses indicate that the foundation blocks show evidence of exposure far predating the Roman structures above. This reinforces the notion that Baalbek's platform is a relic from a vastly earlier era, inviting a reconsideration of regional prehistoric engineering capabilities. The profound functional focus of the foundation, devoid of decoration and purely designed for stability, contrasts with the ornamental Roman superstructure. The silence of Roman historians, who meticulously documented other engineering feats, remains one of the most puzzling aspects. If Romans had engineered Baalbek's massive foundations, why is there no mention in Plautus, Vitruvius, or Pliny the Elder? This absence adds weight to theories proposing a different origin for the foundation, outside the official historical narrative. Whatever the truth, Baalbek's foundation challenges conventional timelines and assumptions about ancient civilizations. Its origins whisper of a lost chapter in human history, and its builders remain an enduring mystery, inviting us to rethink the past and imagine the incredible capabilities of those long gone. The mystery of Baalbek's foundation propels us toward a deeper appreciation of its lasting impact and the modern efforts to unravel its secrets. Enduring impact and modern investigations, Baalbek's foundation has stood for over 2,000 years, enduring the test of time and some of the strongest earthquakes in the region without shifting or cracking. Lebanon is situated along a seismically active fault line, and throughout history, powerful tremors have toppled the massive Roman columns that once lined the temple complex. Yet beneath this devastation, the megalithic platform beneath remains perfectly intact, a testament to the extraordinary engineering skill of its builders. Modern engineers marvel at the seismic resilience built into the foundation's design. The tightly interlocking stones allow the structure to absorb and dissipate seismic forces, enabling slight movements without catastrophic failure. This advanced understanding of earthquake-resistant construction is remarkable for any era, let alone one so remote in history. It highlights that the builders not only moved massive stones, but also applied sophisticated architectural principles that still impress today's specialists. In recent years, technological advancements like three-dimensional laser scanning and ground-penetrating radar have shed new light on Baalbek's hidden complexities. These tools reveal that the visible megalithic platform is only part of a larger, deeper foundation system. Beneath the surface lie additional massive stones and architectural features that have remained undisturbed for millennia, suggesting that much of Baalbek's engineering marvel is yet to be fully uncovered. Excavations and remote sensing have encouraged reassessments of Baalbek's construction timeline and purpose. The evidence of weathering on the foundations points to exposure far predating the Roman temples. This supports the theory that Baalbek's most impressive architectural base was crafted by an earlier, possibly Bronze Age civilization with advanced knowledge now lost to history. If so, the Roman works above can be seen as an adaptation rather than an original engineering feat. The sustained interest in Baalbek has led to numerous experimental reconstructions attempting to replicate the quarrying, transport, and placement of the huge stones using period-appropriate technologies. These efforts consistently conclude that nothing available in the Bronze Age or Roman era could have managed the work with the precision and scale seen here. This consensus pushes scholars to consider alternative explanations or acknowledge that ancient builders had mastered techniques beyond current understanding. UNESCO has designated Baalbek a World Heritage Site, primarily recognizing its Roman ruins, yet the foundation, the true unsung hero of the complex, remains at the fringes of public and academic attention. The monumental base is integral to the temple complex's stability and grandeur, yet most visitors miss its significance, drawn instead to the columns and upper structures. This imbalance mirrors the broader challenge of recognizing achievements predating and overshadowing Roman imperial narratives. Some modern theories speculate about lost technologies that might have enabled this engineering mastery, from advanced counterweight systems to forms of acoustic levitation. While these ideas remain controversial, they underscore the limits of our current archaeological and historical knowledge. Baalbek challenges entrenched assumptions and invites us to remain open to the possibility that humanity's ancient past holds surprises still waiting to be understood. The enigma of Baalbek forces a re-evaluation of ancient history, technology, and human capability. It reminds us that historical records only tell part of the story, and large swaths of knowledge may have been lost to time. Each new scientific investigation adds pieces to the puzzle, but also deepens the mystery, urging persistent curiosity and respect for the achievements of cultures we may never fully know. Ultimately, Baalbek is a monument not just of stone, but of human ingenuity carved into history's deepest layers. Its foundations defy explanation and invite us to look beyond accepted narratives, to marvel at engineering feats almost incomprehensible even today. The truth behind Baalbek's greatest mystery remains elusive, but its impact on our understanding of the ancient world is undeniable. Baalbek's foundation stands as a silent challenge, a testament to ancient engineering that continues to baffle us. From colossal stones heavier than jumbo jets to precision cuts and seismic resilience, it reveals a hidden chapter of human history. If you enjoyed uncovering this mystery with me, please like and subscribe for more explorations into the world's greatest enigmas. Your curiosity drives the journey.